Hi, fourth graders. This is our video for Math Lesson 79, found on pages 501 to 508 in your book. The topic of our lesson tonight is symmetry. Now, symmetry is a balance in the appearance and the structure of an object. Lots of things in nature have symmetry. One kind of symmetry is called reflexive symmetry. In this kind of symmetry, I could draw a line down the center of an object and cut it in two exactly equal halves. It's called reflexive symmetry because if I took one side of my butterfly here and reflected it over the line that I drew, the two sides would match up equally. Take a look at example 1 down here. Do any of these polygons have lines of symmetry, reflexive symmetry, and which ones? And then we want to find which polygon has no lines of symmetry. Well, my rectangle here in letter A, if I draw a line like this, I could reflect this half of my rectangle over onto this half. So that's a line of symmetry. I could also draw a line of symmetry like this. If I reflected the bottom half of my rectangle up over this line, they'd line up exactly too. Shape B is an isosceles triangle. It's got two sides that are exactly the same length. Does this shape have a line of symmetry? It does. If I reflected one half of my triangle over this line, it would exactly match up with the other half. What about shape C? This is a trapezoid. I don't see any way to cut this shape in half evenly. If I draw a vertical line like this, the halves don't match up. Same thing if I draw a horizontal line. The bottom and the top wouldn't match. I could try a diagonal line corner to corner, but those two sides wouldn't match up either. And neither would those. So it looks like C is my shape with no lines of symmetry. Now D is a square. It has many lines of symmetry. I could cut my square in half going up and down like this, and I could reflect one side over the other. I could draw a line of symmetry here, or I could reflect the top of my square down onto the bottom. Squares are special. They also have lines of symmetry corner to corner. Can you think of a shape that has an infinite number of lines of symmetry? If you can, write the name of that shape somewhere on this page. It doesn't matter where. For example 2, we're going to look at the letters in the word chair, and we're going to decide which of these letters has a line of symmetry, or more than one, or none at all. So look at the letter C. Is there a way to cut the C in half so that one side could reflect over onto the other side? If I try it this way, I'm just going to lay my pencil down and I can see right away the two halves on either side of my pen don't match. What about this way? Yeah, that could work. The C has one line of symmetry, a horizontal one. The top of my C could reflect down and match with the bottom of my C. What about my letter H? If I cut it in half vertically, do the two halves look identical? They do. I could reflect my H one half over onto the other. I could also cut my H in half this way and reflect the top onto the bottom. What about my letter A? Do we have any reflexive symmetry in this letter? Yep. I can cut my A in half vertically, and then the two sides could reflect onto one another. If I try and cut it in half horizontally, though, it wouldn't work. The two sides would not match up. My letter I, can I cut it in half vertically? Yes. If I do that, I can reflect one side over onto the other. What about horizontally? Yeah, that works too. My letter R, nope. If I draw a line vertically, the two sides on either side of my line would definitely not match up. What about horizontally? Nope, that doesn't work either. So my R has no lines of reflexive symmetry. Now there is a second kind of symmetry called rotational symmetry. This one I was not familiar with. This was new to me. A shape has rotational symmetry if it matches itself every quarter turn, which is 90 degrees, or every half turn, which is 180 degrees. Now this is a little tricky to draw. What I tried to draw was my shape, a square, and I wanted to show it rotating 1/4 of the way around and then 1/2 of the way around. So I colored in 1 corner of my square to show that how it was flipping. So I took my square and I rotated it 1/4 of the way. That's 90 degrees, and it matches. The shape matches. Don't worry about the corners matching up. Then I took my square and I rotated it a little more till it was halfway around, 180 degrees. So a square has rotational symmetry because every half turn or quarter turn, the shape matches itself. Let's take a look at the shapes I've given in example 3. We want to take a look and see which of the shapes does not have rotational symmetry. I find it to be easier to think these problems through if I can actually twist the shape around in front of me. So I'm going to take a card and make a sketch of my first shape here. Wasn't a great sketch, but we get the point. Alright, what I'm going to do is I'm going to rotate this shape 90 degrees and then 180 degrees and then 90 degrees again and then back 360. Did the shape match every half or quarter turn? No, it didn't. Half, or here's the original. There's a quarter turn. Did it match? No. Here's a half turn. Did it match? No. Another quarter turn. Did it match? No. Okay, so this one doesn't. Now shape B. Wait a second. My math book is telling me something different. It's telling me that my shape can have rotational symmetry if it will match itself every third of a turn too. A third, a third, a third. Okay, in that case, this one does. Oops. My next shape is a rectangle. I'm going to turn my rectangle 90 degrees. It doesn't match. And I'm 180 degrees. Yep. Okay, this one will match if I rotate it around. Alright. Alright, now ignoring the fact that my my hexagon is really not that great of a hexagon. Let's give this a try. Can I rotate this so that it looks the same? Oh, there's a match. There's a match. There's a match. There's a match. Okay, my hexagon has rotational symmetry. And last but not least, I have an isosceles triangle. Let's rotate that. See if we can get it to match itself before we get all the way back around. No, we couldn't do it. We had to get all the way back around. So this triangle, this isosceles triangle, is the one that has no rotational symmetry. I'm sorry, I think I was a bit confusing about that. We will go over rotational symmetry together in class tomorrow. For your practice problems, I want you to practice reflexive symmetry. So that's drawing lines of symmetry. I want you to copy down the shapes A, B, C, and D, and I want you to draw the lines of symmetry, if there are any. Have a good night.